Hi, myself Salim Khan. Today I will discuss about the 2D and 3D graphics with OpenGL. First, we will see about the introduction of 2D and 3D graphics with OpenGL. OpenGL is a powerful cross-platform API for rendering 2D and 3D graphics. It provides developers with a set of functions to interact with the GPU for rendering high-quality graphics. OpenGL can be used for a wide range of applications, including video games, simulation, and visualizations. Next, we will discuss about the basic concepts of OpenGL. OpenGL uses a state machine model where various states define how rendering commands will be executed. The rendering pipeline in OpenGL consists of multiple stages, including vertex processing, primitive assembly, rasterization, and fragment processing. Objects in OpenGL are defined using vertices and various attributes such as color, texture, coordinate, and normals. Next one is a 2D graphics in OpenGL. In 2D graphics, OpenGL can be used to render shapes, textures, and images onto a 2D coordinate system. The use of orthographic projection in OpenGL simplifies the rendering of 2D graphics by projecting objects onto a 2D plane. 2D transformations such as translation, rotation, scaling can be easily implemented in OpenGL for creating dynamic 2D graphics. Now we will discuss about the 3D graphics in OpenGL. OpenGL excels in rendering complex 3D scenes with realistic lighting, shadows, and texture. 3D graphics in OpenGL involve defining 3D models using vertices, normals, and texture coordinates. The use of perspective projection in OpenGL enables the rendering of 3D objects with depth and spatial realism. Next one is the shading in OpenGL. Shading in OpenGL refers to the process of determining the color of pixels in a rendered image. OpenGL supports both fixed function pipeline for basic shading and programmable shaders for advanced shading effects. Vertex shaders or fragment shaders in OpenGL can be customized to implement complex lighting models and material properties. Texture and mapping in OpenGL. Textures in OpenGL are images applied to 3D objects to add detail, color, and surface properties. Texture mapping in OpenGL involves mapping texture onto 3D surfaces using texture coordinates. Various texture filtering and wrapping modes in OpenGL allow developers to control how textures are applied to objects. Now we will see about the buffers and frame buffers in OpenGL. Buffers in OpenGL are memory locations used for storing data such as vertices, color, and texture. Frame buffers in OpenGL are used for rendering images off screen before displaying them on the screen. Double buffering in OpenGL prevents visual artifacts by rendering images to a back buffer before swapping with the front buffer, as more you can understand in the diagram. Optimization techniques in OpenGL. OpenGL provides various optimization techniques such as batching, culling, and level of detail to improve rendering performance. Using vertex buffer objects and index buffer objects can reduce the overhead of transferring vertex data to the GPU. Implementing first term calling and occlusion calling in OpenGL can improve the efficiency of rendering by skipping unnecessary objects. Cross-platform development with OpenGL. OpenGL is supported on multiple platforms, including Windows, Linux, iOS, and Android. Cross-platform development with OpenGL allows developers to write graphics applications that can run on different operating systems. Libraries such as GLFW, HDL, and GLEW provide abstraction and utilize for creating cross-platform OpenGL applications. In the end, we will discuss about the conclusion. 2D and 3D graphics with OpenGL offer a powerful and versatile platform for creating visualized stunning applications. By leveraging OpenGL capabilities in rendering, shading, and optimization. Developers can achieve high-performance graphics rendering. Continued advancement in OpenGL and the OpenGL shading language make it go-to choice for graphics programming in various domains.